Hello, everyone, and welcome to this webinar. It's a big pleasure to have you all with us today. I will be presenting this webinar to you, so let me introduce myself. My name is Luis Gustavo, and I've been working with WEG for the last 7 years as a sales engineer. Also adding to my backgrounds, I've worked several years as an electrical system designer and also electrical panels designer. Good, now that you know me, let me get to the agenda for today. This is our agenda for today. With these topics, we will explore a little better both techniques, cascading and type coordination, and also check some practical examples. At the end of this presentation, there will be some open minute for questions, which will be answered by our sales engineer that are supporting this webinar. You may also type your questions in any moment during this presentation, and they will be glad to answer them. So let's get it started. Before we move to the protection techniques, let's check some basic information in order to better prepare us for the upcoming subjects. We shall explore very quickly the normative and the main terms and concepts that concern both techniques. Well, first of all, let's start reviewing some important terms which will be mentioned in this webinar. MCB stands for Miniature Circuit Breaker, MCCB as Molded Case Circuit Breaker, SCCR, Short Circuit Current Rating, ISC as the Short Circuit Current, ICS, Rated Service Breaking Capacity, ICU as the Rated Short Circuit Ultimate Breaking Capacity, IN as the Rated Current, IP, Prospective Current, and I2T stands for Electrical Energy. So, about the normative, we start mentioning the IC 60898-1. The International Electrotechnical Commission, IEC, is one of the world's leading organizations that publishes standards for all electrical and electronic fields. IEC 60898-1 relates to AC low voltage circuit breakers for household and similar applications, which we find in homes, schools, shops, and offices. The standard states that the maximum value rated current is 125 amps, and the maximum value of rated short circuit capacity is 25 kiloamps. Now the IC 60947-2. This IC governs circuit breakers for industrial applications. They protect electrical power distribution of up to 1000 volts alternate current and 1500 volts direct current, with an entire spectrum of rated currents from 0.5 to 6300 amps. IC 60947-4-1. Also applicable to this webinar, there is the part 4-1, which established the requirements for motor starters and contactors for industrial applications. Both aforementioned parts of IC 60947 are the ones which regulate the protection techniques that we will check further. So keep in mind that they are within an industrial environment. Now let's check some basic technical concepts. Breakers limiting capacity. The limiting capacity of a circuit breaker is its aptitude to let through a current during a short circuit that is less than the prospective short circuit current. In other words, if a breaker is a limiting device, it shall limit the fault intensity felt by the other components downstream. In order to make it possible, the limiting device shall be capable of interrupt the fault in less than half-wave cycle. Note in the picture that the limited peak current is much lower than prospective peak current, which is the one that would be felt by the downstream devices in the absence of a limiting device. In consequence of limiting this current, the total I squared T, which is the fault energy, is also reduced. Remember that the same concept applies when we specify a fast-acting fuse to protect a semiconductor device, for example, a VSD. We shall always guarantee that the limited I squared T is lower than the max I squared T that the component may withstand. Please keep in mind this energy limiting concept because it will be the base for the next techniques that we're going to see. Moving to the first technique, we will now check about the cascading, which is a cost-effective technique to raise breaking capacity. With this technique, the upstream breakers limits the fault current or prospective short circuit current in a way that the downstream breakers can operate at normal conditions at that given SCCR. In other words, the upstream device acts as a barrier, limiting the electrical energy in a magnitude that can be withstood by the downstream devices. The possible combinations are tested and determined by the manufacturer and shall be linked with the corresponding product line and current range. Now let's look for a practical example. The same breaker configuration. A molded case circuit breaker as the main breaker, or upstream breaker in this case, and miniature circuit breakers as the downstream devices. The MCCB is a WEG DWB model. This one rated for 30 kiloamps at 400 volts. The miniature are WEG model MDWH and rated for 10 kiloamps at the same voltage. Looking to the system requirements, it is stated that the short circuit levels at the installation point may reach 25 kiloamps. In this case, if no cascading is applied, the miniature breaker shall not be part of this panel, as its interrupting capacity is lower than the informed SCCR. So let's have a look at WEG cascading table and check if we may find a solution. At WEG MCCB plus MCB section, you will find the following table. So on the top left corner, we have the system line voltage, in our case 400 volts. Still on the top cells, you will find the upstream devices, and in the left column in the lower lines, there will be the downstream devices, which may be associated with those upstream devices. The upstream breaker that we are looking for is a DWB 160N. The downstream devices are MDWH up to 63 amps. Then, we have a reinforced SCCR of 25 kiloamps for this association. Back to our example. Note that now we have a cascading association for these miniature breakers, and as a result, we have a reinforced short circuit rating of 25 kiloamps. With this, the MCBs are now within the SCCR limit request, and we've got a cost-effective solution. This association is not limited to only 2 consecutive circuit breakers, but to all the circuit breakers downstream. So again, cascading is a technique associated with current limiting. Circuit breakers with breaking capacity less than the prospective short circuit current may be installed downstream of limiting circuit breakers. The breaking capacity is reinforced by the limiting capacity of the upstream device. As a result, you may have substantial savings on downstream protective devices and also a significant panel enclosure size reduction. Important to bear in mind that in a fault event, both breakers, upstream and downstream, may trip. So pay attention to these applications where it may affect critical circuits sharing the same upstream protection. Good. Now that we have explored the concepts of cascading technique, let's move forward to the type coordination. Back to the normative. Remember that IC 60947-4-1 established the requirements for motor starters and contactors, and also governs the requirements of type coordination, generally applied in motor circuits using such components. The type coordination is a technique that ensures safety to the users and may also ensure viability of operation by reducing machine downtime and maintenance after a short circuit. It is extended to the motor control and protective components like contactors and overload relays. So let's explore together the main differences between these two types and where each one shall be applied. Coordination type 1. Due to its lower component cost, this is the most frequently used solution. In a coordination type 1, under a short circuit condition, the contactor or starter must not present any danger to personnel or installations and must not be able to resume operation without repair or replacement of parts. In other words, safety is guaranteed. However, the service continuity is not. Circuits having such coordination shall also demand a more skilled maintenance personnel. Many industries are dependent upon the continuous operation of critical manufacturing process. In these conditions, it's important to understand that type 1 protection may not prevent damage to the motor starter components. In order to ensure that short circuit events does not interrupt the critical process, it may be prudent to consider implementation of type 2 coordination in the selection and application of low voltage motor controllers. In a coordination type 2, under a short circuit condition, the contactor or starter must not present any danger to personnel or installations and shall be suitable for further use. The risk of contact welding is recognized, in which case the manufacturer shall indicate the measures to be taken in regards to the equipment maintenance. Thus, safety and service continuity are guaranteed. So let's check another example. Let's find the most suitable control and protection set for the following motor. 18 amps at full load, rated voltage is 400 volts at 50 Hz, and the required SCCR at the installation point is 35 kiloamps. This is a critical application where service continuity must be guaranteed and customer is looking for a simpler solution, having only a motor protective circuit breaker as the protective device and a contactor as the control device. So let's take a look at WEG Type 2 coordination table. We're looking for a 35 kiloamp short circuit rating. However, the right next one is 50 kiloamps according to WEG tables. Now that we found the proper Type 2 coordination table, let's look for the combination components. That's it, simple like that. Now we know the right references for the protective device and control as well. This combination of components will guarantee a Type 2 coordinated motor circuit, thus also granting safety and service continuity. Now that both techniques have been explored, let me show you what WEG has to offer concerning it, and where you may find the combinations recommended for that. WEG counts on its own testing laboratory, accredited by international bodies such as DECRA and UL. This is a continuous work. Besides, we have a wide range of possibilities already tested and listed in our literatures. Our engineering and laboratory keep working on new combinations and new ratings. We count with cascading combinations for the whole line of WEG MCBs and MCCBs, a large selection of type coordination involving motor control and protective devices, and coming very soon, WEG is glad to announce that selectivity combinations, also called discrimination, will be part of our technical solution in order to support very demanding installations. All WEG tables related to these techniques may be found in a special catalog available at our website. Let's review some common questions before we move to the open chat with our engineers. Where exactly I may find WEG coordination and cascading tables? The tables are available at the link below. You may also find them at our website by searching it. As WEG is working in the continuous improvement of these tables, always check for the updated version. Is it necessary any certification document in order to validate such tables? No. Each manufacturer is responsible for the information that they publish in their catalog. However, they shall follow to the letter the corresponding IC requirements, and it must always be validated through laboratory testing. Regarding cascading, may I always apply it for industrial installations when it's possible? As this technique relies on the use of simpler spec downstream devices applying the current limitation concept, it is always recommended to check with the customer or in the user engineering if cascading is acceptable. Ladies and gentlemen, with this, I'm finishing this presentation to you. I hope that I could show you the main aspects of these protection techniques and where you may apply them. Please let us know if you have any questions left. Our team is here to support you with that. Thank you very much for your time and see you all in the next webinar.